In this video, we're going to be looking at Boolean operators for AQA's GCSE in computer science. There are three Boolean operators that you'll need to be aware of, and you need to be able to use them when programming. They are AND, OR, and NOT. Boolean operators can be combined together or used alongside relational operators to build complex Boolean expressions. The Boolean operator AND requires that both conditions are met, whereas OR only requires at least one of the conditions to be met, and NOT simply reverses the result. On the screen here, there's some basic examples, but let's take a look at some more interactive ones to get a better idea of how it works. In these examples, we're going to use pets, and to keep it simple, we're just going to focus on cats and dogs for now. So, in order for an AND Boolean operator to work, you must own both a dog and a cat. It's not possible to own a dog on its own or a cat on its own. You must in fact, as shown here in green, own both a dog and a cat. Now an OR requires that only one of the conditions is met. This means that you could own a dog on its own, a cat on its own, or both a cat and dog. Now let's take a look at NOT. Now here I own a cat but not a dog. So therefore it also means that I can't own a cat and a dog because I own a cat but not a dog. So here I'm showing the Boolean operators that we're currently learning about and the relational operators we learned about in the previous video. Let's have a look what happens when we combine them. So in this example here we're using the Boolean operator of AND and the relational operator of equal to. So we're checking basically if the animal is a dog and it's wearing a collar. Remember that both of those conditions must be true in order for the AND to work. So straight away we can look at all of the animals and anything that's not a dog we can discard. So I've got rid of two cats and a chicken. Now the two remaining ones are both dogs. However, one of them doesn't meet both conditions. So if we look closely, it's the animal is a dog and wearing a collar. So you can see that the first dog is in fact not wearing a collar. So the second dog meets both conditions. So here I've tweaked the criteria slightly to show you that sometimes AND isn't the correct operator to use. So here I'm checking that the animal is a cat and a dog at the same time. Think about that logically. The animal is a cat and a dog at the same time. Well, that's not possible, so we know straight away that all of these would not meet the criteria. How could I change that and make that scenario work if I wanted either a cat or a dog? So hopefully you've just said that you'd change the AND to an OR. So let's try that scenario then, but instead of using AND, let's use OR this time. So the animal is a cat or a dog. So let's go through them. So this one is a cat, it's met one condition, so therefore it's true. This one's a dog, it's met one condition, so therefore it's true. This one's also a dog, so it's met one condition, so it's true. This one's a chicken, so it's not a cat or a dog, so it's met neither of the conditions. And then finally, this one's a cat, so it's met one of the conditions. So you can see the clear difference there between and OR. Finally, let's take a look at an example using NOT. Now I've wrote this in two ways. I've done it using an exclamation mark and equals, which is using relational operators, and the second way I've done it using a Boolean operator, as well as using double equals, which is a relational operator. Okay? Both of those would do exactly the same. It's a little bit like when you're programming. It's quite common that people come up with the same result, but they've done it in different ways, and that's nothing to worry about. So here, the way I like to do it is, I like to ignore the NOT to start off with. It says animals equals cat. So I find anything that's a cat, and then I apply the reverse of it. So I don't want cats, so I NOT them, which means I would ignore them. Okay? And then I return anything that's not a cat. So therefore I'd return a dog, and a chicken in this case. It's important that you recognise that computing relates heavily to maths. You can see here how I'm using BODMAS stroke BIDMAS to begin to solve this problem. So you can see how I'm starting off by looking at the individual brackets. Okay? Remember that NOT reverses the result before we go any further. So earlier on, I said that you can combine Boolean operators and relational operators to solve complex Boolean expressions. So let's break this one down using BODMAS stroke BIDMAS and see how easy it is to solve. So I've highlighted in red, blue and green the key main parts, basically the brackets. So we'll bring those down. Okay? Let's take a look at the first one. NOT 5 is less than 4. So let's forget about the NOT for a second. Okay? Let's just look at 5 is less than 4. Now we know that 5 is not less than 4, so that gives us false. Now earlier on you heard me say that not just literally reverses the result. So if we reverse false, we get true. And that's the easiest way to do it. So now I've got 6 is less than 12. Now we know that 6 is less than 12, so therefore that would output true. I've then got 10 equals 9. Now we know that 10 is not equal to 9, okay? So therefore that would be false. Let's substitute these back into the original problem and see if we can solve it. So here we've got not 5 is less than 4, and then we know the result of that part is true. We've got 6 is less than 12, and we know the result of that part is true. Now I've highlighted this part here in the green square to show that it's an AND statement. So in order for this to be true, remember both parts have to be true because AND requires both conditions to be met. So they are both true, so therefore they have both been met. So overall that AND statement would return true. Okay? Now notice we've got the OR to still do. So 10 equals 9. Is 10 equal to 9? Now we know that's false. So we'd bring that one up and we'd substitute it into the orange part there. So now we've got the AND part is true, okay, and then the part after the OR is false. But bear in mind that this is now controlled by the OR statement. So basically, if the green part is true or the orange part is true, well then the overall outcome will be true. So when we run that look, we then get true as an overall outcome because the OR is dictating that either one part of the statement or the other part of the statement is true. And we've done that using BODMAS or BIDMAS. You might want to pause here and have a look at that in more depth because it's quite difficult to get your head round while I'm talking. So if you want to check your understanding, what you could do is have a go at coding it. So if you want to now pause the video and have a go, do so because I'm going to show how to code it in 1, 2, 3. So here's the code. So what you could do now is have a play by altering some of the conditions on line 1 using Boolean operators, combining them with relational operators and see what you can get it to do. Finally, here in this example, I've altered line 1, I've removed the NOT gate altogether on the second example. So this means now that 5 is less than 4. Now that's false in this example because obviously it hasn't been knotted. This will alter the program and the output. It might be worth having a play with these just to get your head around it. You should now have an understanding of the Boolean operators AND, OR and NOT. Thank you for watching. I hope you enjoyed that video. Please remember to check out some of our others.